Thank you everyone for joining this meetup, and thanks for joining my talk. I'm super excited to be here after some time, just having a physical kind of event here. Also, thanks for everyone online for joining this this talk today. Believe it or not, I was struggling to find my way to here. I had a bit of hard time to just cross the roads and everything. So eventually I'm here. So thanks everyone for joining. My name is Bahman. At the moment I'm a technical lead at Telstar Health. Before Telstar Health, I was a consultant at Telstar Purple, and before that, Redify. I've been working in development industry or IT industry for quite a while now. The experience that I want to share with you today or tonight is based on my recent experience that I had in Telstar Health to convert or bringing a legacy data application to Kubernetes. Come on, it should work. Sorry. Should have tested this. That's okay. Doesn't work at all. Okay. Yeah. All right. Telstar Health is one of the major software providers for pharmacies, hospitals, and aged care sector in Australia. They have a particular application called Clinical Manager, which I'm going to talk about. Clinical Manager is a website that aged care providers are using to manage the clinical information of the aged care residents. This particular application has been around for quite a while, around 15 years in the market. And I think more than 200 aged care providers in Australia are using it. And it's actually has got the largest market share in Australia in the aged care sector. So it's an old application that has been around for a while, and it has been a successful one, and clients are using it still in 2021. So this is the application that we are working on. But what was wrong that we wanted to change there was something about the infrastructure of the application. So if you consider our application, or if you compare our application to a ship has got everything that it needs to be able to run. So our application is, or any application is probably the same. It has got the code, it has got, we are using our application in Windows, so it has got iOS, Windows, and whatever component that it needs. So everything, if you consider everything that you need to run this application, compared to a ship, what we have at the moment in our infrastructure is this. We have more than 200 different ships running around, because this application is an old one. It's a single tenant application, and for each individual client of ours, or each one of those aged care providers that I said, we have a virtual machine, and we run the application there, and then they can use it in their organization. So obviously this is not the picture that we want to maintain. We were thinking still have one ship, but and manage everyone there, but without a drastic change on the application code. Now, why we wanted to make this change? Why we wanted to change the infrastructure? These are the reasons that we were thinking. better maintenance, cost saving. We wanted to have saving on the cost, better performance, more scalable solution, better or improved security, make it easier for us to support, better disaster recovery plan, higher availability, and eventually better or more benefits for our customers who are the edge care providers. Now, before I continue, let me just briefly talk about the technologies that we have in this legacy application. As I said, the development of this app started 15 years ago. So they started with ASP Classic. Then later on, ASP.NET Web Form came along, and they used the ASP.NET Web Form. And back on those days, probably it was a good idea to use jQuery with ASP.NET Web Form as well. Later on, ASP.NET MVC came along. Web API was another thing. AngularJS was a breakthrough in probably in the front-end technologies. Some developers were more comfortable with React, and eventually Angular has been kind of a standard for the development to work with. At the moment, apart from ASP Classic, we have a bit of everything in our tech stack. So throughout all of those development years, always there has been a challenge to redevelop the older codes, and the development team tried the best to move away from the older technologies, but we still have a bit of ASP.NET Web Form, for example. So at the same time that the new features were added to the application, the development team was converting the code to a newer technology, but nothing has been completed. So we still have a bit of legacy code in our solution. And because the clients are using it, it's very hard for us to justify, just throwing everything away and redo everything from the scratch. So this is the tech stack. About the database also, we have been using SQL Server, and we were using Microsoft SQL Server reporting service, which we are not using anymore. We just stopped using it after transforming the infrastructure. Now, all right, so we knew that we have a legacy application. We have a legacy application. We wanted to improve our hosting experience. Now, what were our options? So before this project that I'm talking about, we were using infrastructure as a service for hosting our application. Now, we were thinking to use platform as a service. And because we are using Azure heavily throughout the organization, so we were thinking to use one of the PaaS offerings in Azure. In terms of the database, we agreed that our best option is moving to Azure SQL. But in terms of the web part of the app, we were thinking to either use Azure App Services or Azure Kubernetes Services. Eventually, after doing some research and proof of concept, we thought that AKS would be the best option for us. And the main reason was, again, the same picture that I showed you. We want to have everything, all the clients under the same roof. And in terms of, in regards to AKS, Kubernetes will be the captain of our ship. Now, now that we knew that we wanted to move to Kubernetes, the next step was containerizing our application. So I showed you the tech stack. We are not using ASP.NET Core or .NET 5 or 6. We are using ASP.NET Framework 4.8. And it's not easy for us to change that picture for now. So that means that we couldn't use Linux containers, and we had to use Windows containers. So we thought that as the beginning, let's do a proof of concept, and let's try to run our application in a Windows container and then eventually host in AKS. We came across this tool, which is not a new thing, but it's I think it was a very useful thing for us. It's a PowerShell module that you can use, and you can point it to a virtual machine that your application is running, and this will create a Docker file for you, and then you can use that Docker file to build your Docker image. That was a very good starting point because we had no idea how to understand how to come up with all the settings that we had in our Windows machines, like all the IIS settings. That helped us a lot to get started. So we created our first Docker image, and then we ran it in AKS. And we saw our application working, and we had a automation test suite, and we ran the test on the new environment, and it was looking good. So there you go. We realized that all good. That was very easy, and we could have gone home after that. Well, we went home. We went home anyway, all of us. But we still had to work on this. So the very next question that we asked ourselves was, is it okay if we put everything, all this big application into one container and saying that we containerize the app? It was probably okay, but we thought maybe we can improve our experience or our development experience a little bit. So this is a very high level view of our application. Those boxes they could be just a single class, a folder, a library, as an application. There are many things here, and this is a very simplified version of our code, our monolith application. So as you can see, there are many relations around, and it's very hard to break these dependencies. So instead, we thought what we can do, maybe we can draw a line somewhere, and we can divide the big application into two kind of sub-applications or two containers. And let's call one legacy, another one modern, because that's probably the best name for them. For the legacy part, so this dividing was based on the technology. So the reason that we did that, we knew that the legacy code, things like ASP.NET Web Form, for example, there's no way to convert them to ASP.NET Core or .NET Core or .NET 5. So we had to, at some point, we had to rewrite them, I think. But the modern code, in theory, we were able to convert them to newer version of .NET. So by breaking the application into two pieces, we kind of future-proof our application so that we can make upgrades on the modern side of things and get rid of the legacy eventually. The next thing that as a non-container developer, we realized that in containerized world, if you want to inject your configuration values to your application when you're deploying it, you have to find a way to inject them, obviously. So in Linux, sorry, I just need to exit a couple of applications here. Sorry, I had something open that probably people were putting a lot of messages there, so better to stop it now. I assume that everyone can see online as well. All right. Yeah. So in non-containerized world, if you want to deploy your application, or the way that we used to do was using web.config transformation. So we have these web.config files in our application, and when we wanted to deploy them in a new environment, we just transform the values in there, and we just change the value on the physical file and deploy them. But the same because in containers, whatever you when you build your container image, whatever value that you have, it will be baked into the container. So we had to use configuration builders, which was a way to actually inject configuration values to containers. It's actually a NuGet package that Microsoft provided, and it's mainly for Windows containers. The way that you use it is by after installing the NuGet package. If this is your web.config files, you can, in web.config files, you usually have an app settings section that are your application settings section. In there, you specify your config builders type or name, which you define up there. And the way that it works is if in your machine or in your container, you have an environment variable with the same name as service ID or service key, as you can see, then the application will use the values from the environment variable. So this is very easy to do in Linux containers, but in Windows containers, you have to do it this way, for now at least. Another thing that we had to work on was the time zone. That time zone by itself is not an issue about moving to Kubernetes. It was an issue when we wanted to move from infrastructure as a service to platform as a service, and that's probably an issue for most of the old applications. Luckily, we had some initiatives during the last couple of years that we changed many of the dates that we were saving into our database to UTC time zone, but we still had some places that we were getting the server time. So, for example, if in C# you do datetime.now or datetime.today, you get the server date. So the problem was in our infrastructure as a service, we had the servers set up as local time zone, but in our PaaS environment, everything was in UTC. So all these dates were wrong. So we had to go through them and fix them one by one. This is actually one of the major challenges that we had in our way to PaaS. Another thing was our code was not ready to run in a load balance environment. So the problem was that many probably the developers that were working on this application long time ago. Their assumption was that always there will be a server, and there will be just single server, and the application will run on there. But in Kubernetes, that's not true. I mean, you can. I think that's the main power. You can have multiple instances of your application running around, and your application should be able to run, should be able to work in an environment like that. Some examples. Previously, we were doing local files for saving the application logs. That didn't work in our new environment, and we had to change them. Instead, we use Azure Application Insight. Also caching. We used to do some in-memory caching, And again, you cannot just cache something in a pods or in just a single machine's memory and say that I cached it if you have multiple servers, multiple pods running in your Kubernetes cluster. So again, for that, we opted to use Azure Redis Cache. Also, we had some instances that we were saving local files temporarily in the application so that they will be processed later on. Again, the same problem. We had to replace them. We had to change the code there. Less known issues. There were some issues that we didn't have any idea that we will face them. This application has got many integrations with some other third parties and other applications. And one particular integration, for that we needed to install a certificate on our server. And that was a government service that we had to use. So that obviously, again, we couldn't do the same easily on a container, and we didn't want to bake in a certificate in the container. So we had to come up with an alternative, but again, we spent some time to find a better approach to do that. There was another interesting thing that we came across was we were using a very old library that it needed a license file sitting next to the DLL of that library. It was just physically had to be next to the library, the DLL file. So we were lucky that we could de-scope that one. So we just said that we are not going to support that particular part of the code. But yeah, it could have been a major pain point for us if we wanted to support that license. Also, there were some side applications or side applications or components that we were using apart from IIS. So in a Windows, in a typical Windows website, the website that you install in a Windows machine, you need only IIS. But we were using other things like MSMQ, which is a queuing service in Windows. Also, we're using Windows Task Scheduler. So again, for these ones, we had to come up with an alternative. In Kubernetes, for example, we use Kubernetes cron jobs instead of Task Scheduler. There are some limitations when it comes to Windows containers in Kubernetes and in AKS. The first one, I don't know if you call it a limitation. I call it, or probably it's a little bit more work you need to do. So in Kubernetes, you need to have at least one master node. So a node in Kubernetes is just a VM. In order to have a Kubernetes cluster, you need to have a Linux VM at least to be able to run Kubernetes in there. Now, if you want to run your containers in a Windows containers, then you need to have at least one more Windows VM or Windows nodes. You can have more, but you need at least 2 VMs to be able to run an application in Windows container. That's not a problem in managed instances, Kubernetes managed instances like AKS. It's easy to set up, but if you're doing the infrastructure yourself, there's a bit of work there. This is another interesting one. Out-of-memory exceptions are a bit different in Linux and Windows, and that can cause some issues when you want to schedule your resources in Kubernetes. So in Linux, if your a pod is in Kubernetes is just a single object that is running your container. So you can consider it as a web server of your application. If that pod is using more memory than it was supposed to, then that pod can be subject to eviction. But the same story doesn't happen in in Windows, and Windows will slow down and will start paging. One example here, on the left-hand side, you can see a Linux container, Linux VM or a node that has got, for example, 10 gigabytes of memory. I'm not concerned about the CPU here. I'm just talking about the memory. And when you want to schedule your pods or your applications there, you can specify two numbers. One is request, one is limit. So the request is the amount of memory that your application needs, at least to be able to run, and the limit is the top value that your application can use. So if you think your application will use from 1 to 2 gigabytes of memory, then better to set a request to 1 and limit to 2. So it can just go up and down based on its requirement. And the way that you schedule your pods there is based on request. So if you've got 10 gigabytes available, in theory, you can put 10 pods there. But in this photo, I put 9 because 10 is probably too tight. But suppose that we've got 9 pods in that Linux container, in that Linux node. Now, if 2 of them are using their limit, they're using 2 gigabytes of memory, then the total memory will be more than that 10 gigabytes. So Linux will be able to evict or kill one of those pods. Then it will be good again because the memory of the entire memory will be under the limit. But the same story doesn't happen in Linux. So in Windows. If you have the same scenario in Windows, Windows won't kill the pods. It will just slow down. So that's why that you need to use the same number of requests and limit in your Windows containers if you want to avoid any inconsistent behavior. So it means that best you can do is fitting 5 pods there. So there's a bit of wasting in the Windows containers if you can compare to Linux container. I hope it makes sense, but ask me if you have any question. Also, in Windows containers, you need to have at least Windows Server. In Kubernetes, your images need to be from Windows Server 2019 or above. The older images are not supported. Only process isolation is supported for now in Kubernetes. In Windows containers, we've got 2 process isolations. One is called, 2 type of isolation modes. One is called process isolation, which essentially means that your containers are using the same kernel. They are like processes that are separated, but they're still using the same kernel. Another isolation mode is Hyper-V isolation, which each one of your containers, they will have their own, they'll look like virtual machines, so they have their own kernels. This particular isolation mode is not supported yet in Kubernetes. Also, not all features available for Windows containers in AKS. A good one that I really wish be available in AKS soon is Azure Dev Space, that you can, your developers can have their own space on a particular AKS cluster, and they can play there. But this is only available for Linux containers. Also, KubeNet is another thing. It's a network plugin that Kubernetes uses. That again is not available in AKS for Windows containers, but there is an alternative for this particular one in AKS. One thing that I want to mention here is that think about our goal. We wanted to move all clients from infrastructure as a service to platform as a service. And we didn't have any idea what sort of memory profile or what sort of CPU profile we had to come up with for our clients. So we had to do some performance tests to be able to understand what sort of resources we need. And again, that was one of the challenges here, because we don't have one website. We have 200 different websites. So we had to come up with some profiles for our clients, saying that, for a typical small client, this is the workload. For a typical medium client, this is the workload. And we try to simulate the workload on our target infrastructure to be able to get a good understanding about the resource requirements. Having said that, after we deployed to production, I can't say that we got everything right. There were maybe 70% right, but still 30 or to 40% that we had to tweak after deploying to production, despite doing all the work on performance test. Now, get back to the benefits that I mentioned initially. So I think our target platform now is more maintainable compared to what it was before. We estimate that we get some good cost saving here, more scalable compared to what it was before, more secure because we are using Azure services. Also, I think in general, containers are more secure compared to just having a full VM. Better disaster recovery plans, higher availability. All of these come as part of our platform as a service offering that we are using. And we will have better, more benefits to our customers. One of the major pain points that our customers had was the downtime that we had to have when we wanted to release a new version of the application, which could be just 1 hour. And that was a very important thing for our clients. They didn't want to wait 1 hour for us to release a new version. That downtime now at the moment is 10 minutes. Sometimes it's not available at all. I mean, there's no downtime at all. But when it comes to performance, did we get a much better performance? No, we realized that performance in some areas are improved, but there are still some places, especially the older codes, they are taking more time to load. So the performance in some places actually got worse. So we had to, again, work on the performance improvement to be able to at least provide the same performance that we were providing before. And we are doing that, and I think we made a good improvement there. Easier to support. I can't say that our application is easier to support. It's probably different because there are many different things to learn for us as a application support team and the development team. We still need to learn a lot. So maybe in the long term, it will be easier, but at least not right away now. The last part of my presentation, I just want to talk a little bit about the learning, some of the learnings that we got throughout this journey. The very first part is if we have a quality code, if we invest enough in our code quality, we get the benefit when we are doing refactoring or when we are doing transformation of the infrastructure like this. One example was when we wanted to change the logging, the application logging from local file logging to Azure application insight. It wasn't that much hard for us because the right abstractions were done before. We had a good library for logging. We just had to change a little bit on the library that we developed for our application logs. We didn't have to go through each and every files in the application and change the code there. Another thing that we observed was you need to have a close look on the development that is happening on AKS, on Kubernetes, on Terraform, Helm chart, all of these. You need to have a look probably on the GitHub website and on the GitHub on their source and release note to be to have a good understanding about what's happening, because the development rate is quite high there. And if you don't notice, you just blindly want to upgrade to a new version of Kubernetes, for example, then you can end up with a breaking change. So you need to be, you need to look very closely on the development on these technologies. If you can, use Linux containers. If you can upgrade, if you have a legacy application and you want to upgrade, you want to containerize it, if you can convert it to .NET Core and go into Linux containers, do that. But if you can't, still that's not a bad idea to go with Windows containers. But you need to have a plan to upgrade that picture probably in the close future. I think ideally the recommendation is use a Linux container as much as you can, at least with the current situation of Windows containers and all the features available for them. If you have a legacy application, you probably have a legacy process as well. So you don't want to overwhelm the people with the people in your organization with lots of changes. So maybe control the amount of changes that you're introducing. If the people are using a tool that they are comfortable using it, so probably if you can, don't change it. One example, when we changed all the background stuff, all the infrastructure, we didn't change the tools that people were using, for example, Azure DevOps or Octopus Deploy. We were using these ones, and there was no reason to change them. So we can still use Octopus Deploy, for example. And they are happy, everyone is happy using them, and they are comfortable with using them. So yeah, I would suggest just control the amount of changes that you're introducing. Now, if you are taking away a feature from someone, or for example, your support team, you need to come up with an alternative. One example is when we presented this solution to our application support team, we said, all right, this is a shiny new solution in Kubernetes, now you need to use it. And the very first question they asked us was, how can they log into a server and check the IIS logs? And so my answer was, well, if you want to RDP to it like the way that you used to do it before, you probably can't, or it's not that straightforward. But you can, if you want, you can just use some command lines and log into the part in the production. But again, I'm not recommending that because that's probably not the best way of doing it. Instead, we stream the IIS logs for them on the container logs. So if they want to look at the logs, they can. I think that they won't require to check the IIS logs, but in case if they want to look at the IIS logs, they have some way to do it. So that's another learning that I thought is good to share. But eventually, all of this learning, everything has been done. There's always something to surprise you. So be prepared for it. Thank you.